So welcome once again one more time to our YouTube sessions, and today we are talking about curve sketching, which is curve sketching of cubic functions. So we want to focus on curve sketching. So if you are just joining us, you are new to this channel, make sure that you also don't forget to hit a subscription button. You just subscribe and you just also hit notification button so that as more videos are going to come, you'll be the first one to be notified. So let's get into our content of the day. So we are going to talk about curve sketching of cubic function. So for you to be able to sketch cubic function, you need to know that you consider a first, the value of a. So here's the standard, that if f of x, if you are given f of x is equal to ax cubed plus bx squared plus x plus d, so we would need to know the meaning of each and every value in this case. So the first thing that we need to understand is that we need to know the value of a. First condition, a should not be equal to 0. That's condition number 1. So we have two options. So either a is going to be less than 0 or a is going to be bigger than 0. So let's say our a, in this case, if it is bigger than 0, what kind of a sketch are we going to get? So here is a sketch that we have. So we have a sketch of this format. This is the sketch. And we have our y-axis. We also have our x-axis. We also have our local maximum. We also have our local minimum, which are the turning points in this case. So these are our turning points, a local maximum and a local minimum. So what you need to know is that if you have a which is bigger than 0, your curve takes this format. So let's check out if a is less than 0. So having a being less than 0, we are going to have our graph, which is going to take this format here that we have, and we also need to understand our y, our x-axis. So we have our local minimum on this side, and we have our local maximum being on this side. So I want you to check the differences between the first curve and the second curve. The first curve, if a is bigger than 0, we have our local maximum, which is to the left. Our local maximum is to the left. If and our local minimum, it is going to be on the right hand side. Okay. So if a is less than 0, we have our local minimum, which is going to be the one that is on the left, and then our local maximum is going to be on the right. So this is basically what we have. If a, so f of x in this case, let's just draft negative a x cubed plus bx squared plus cx plus d. So given f of x is negative a, we have negative a x cubed plus bx squared plus cx plus d. This is our equation, our cubic equation, and it takes this form where we have a local minimum being on the left hand side, local maximum on the right hand side. Same here, if a is bigger than 0, we have our local maximum being to the left and our local minimum to the right. So this is how we just sketch. It's a sketch. You are not going to draw a curve which is going to be put on the scale. It's just a sketch like this. And let's also talk about the meaning of this number that will be given here. It will be a number. So that d that we have here, our d is going to represent what is called y-intercept. So d represents y-intercept. Same here, d represents y-intercept. So our d is our y-intercept here. This is our d, and we have this is our d. So that's how we basically sketch cubic functions. in this format. So let's check out the question so that we see how do we sketch curves. Now we know about how we sketch these two curves. So we want to see a real question on how do we sketch curve and how do we find some other information if it is missing. So I'm going to put across a question here. Our f of x So let's put across a question so that we can see how do we sketch curve. So let's say we are given f of x being equals to 2x cubed minus 3x squared minus 11x plus 6. So here we have our f of x. So in this case, our f of x, it has a which is positive. So now we know what kind of a sketch are we going to make. Our y-intercept, which is 6. So what we need to sketch cubic equation, like we said, let us start by finding what is called y-intercept. So we find y-intercept by making x to be equals to 0. Let's make x to be equals to 0 in this case. So making x to be equals to 0, we're going to have y being equals to, all these numbers become 0. So 2, 0 cubed, minus 3, 0 squared, minus 11, 0 plus 6. So basically, we are saying if x becomes 0, then we are going to have our y being equals to 6. So the coordinate is going to be x0, y is equals to 6. Okay, now we have our y-intercept. So having our y-intercept, we also need to find what is called x-intercept. So x-intercept, we make y is equal to 0, the opposite of this. So making y is equal to 0 here, we are going to have 0 is equal to 2x cubed minus 3x squared minus 11x plus 6. So if it is a case whereby you are given, let's say you are given one of the factors or one of the x-intercepts in this case. So let's say you are given x plus 2 being a factor. If it is a factor, if x plus 2 is a factor of this cubic function, then we need to be able to test to know whether really x plus 2 is a factor of a cubic function. How do we do that and how do we test? We test with what is called a remainder theorem. We are going to use what is called a remainder theorem to test if x plus 2 is one of the factors. Remember, a cubic function will always have three factors because the cubic function. So x plus 2, if x plus 2 is a factor, then we need to be able to test using the remainder theorem if x plus 2 is a factor. So we're going to substitute x plus 2 into the cubic function. Alright, so this is what happens. If we substitute x plus 2 into the cubic function and we get a 0, then we know that truly this is a factor. So let us substitute x plus 2. If you are given x plus 2, then you need to use the opposite sign. So in this case, we are going to substitute function of negative 2. Why negative 2? Because we are given our factor as a positive. Because x plus 2, making it equal to 0, 2 goes on the other side, becomes negative. So we always know that the standard is that if it's a positive, use a negative. So x function of 2 into this, we're going to have 2 brackets, negative 2 cubed minus 3, negative 2 squared minus 11, negative 2 plus 6. So if we punch a calculator, function of negative 2 we punch a calculator function of negative 2, we are going to see that function of negative 2 is going to give us a 0. So because we got a 0 here, that means this is really a factor. X plus 2 is a factor of this cubic function. But so far we have one factor. We need another 2 factors. So the 2 factors, we're going to get them by dividing x plus 2 into the cubic function. So I'm going to introduce a process, what we call a synthetic method of finding other factors of the cubic function. So I want you to understand this method. How do we use it? So we have our cubic function. This is our cubic function. In this case, our cubic function, and our x plus 2, which is a factor. We make a diagram which is like this. In this case, because x plus 2 is a factor, we are going to put negative 2. So negative 2 goes outside. Where are we getting the negative 2? It's our factor here, x plus 2. Remember I said we put the opposite sign. Then we are going to put our coefficients of this cubic equation, which is positive 2 here. We have negative 3 here. We have negative 11, and we have positive 6. We put them across like this. So the next step is that the first number, we always put it across as it is, provided that we have our factor that we are dividing in, x plus 2. This x is independent. We put 2 first, so we're going to put our 2 down. We bring 2 down. When we bring this 2 down, we are going to multiply this number by this negative 2. So 2 times negative 2 is going to give us negative 4. Then we simplify further by adding these 2. So we have negative 3 and negative 4. So simplifying on a calculator, this is going to give us negative 7. So simplifying further, as long as we get a number here, we multiply that number by this negative 2. So negative 7 times negative 2 is going to give us a positive 14. We got a positive 14, and we also add minus 11 plus 14 is going to give us a positive 3. Once we still get a number which is not 0, because this process is coming from the remainder theorem. Because the remainder theorem gave us a 0, it is true that the number we should get at the end, after keeping on dividing, we should get a number which is also a 0. So 3 multiplied by negative 2 is going to give us negative 6. So 6 minus 6 is going to give us a 0. So once you get a 0, it means we got a quadratic function. Synthetic method, which is this one. This synthetic method, when we do a synthetic method, we are going to get a quadratic function. So our quadratic function, first we have 2, this number, x squared, negative 7x, then plus 3, then 0, we don't write it. So 2x squared minus 7x plus 3, which is our quadratic factor of the cubic function. Let us not lose focus. So once we get our quadratic factor, remember we still have our x plus 2, which is a factor. So what we have just done here is to reduce the cubic function into 2 functions: a linear function, which was a factor given here, and a quadratic factor or a quadratic function. So these 2 are our factors. But to get other 2 factors from this, then you are going to use quadratic method to get this. So let us use quadratic method on this. So x is equal to negative b plus or minus b squared minus 4ac everything over 2a. Now let us substitute our a, our b, our c. We substitute x is equals to negative of negative 7. We get positive 7 plus or minus negative 7 squared minus 4a c, which is 3. Everything divided by 2 bracket 2, which is 2a. So then we are going to make use of a calculator to simplify this. We simplify this on a calculator. We have 7 plus or minus, we put the square root of, we're going to get our values. The first x value, x is equals to, we have x which is equals to half, or the other factor that we're going to simplify when we put our values into the calculator is going to give us x which is equals to 3. So finally we have x being equals to half, x being equals to 3. But let us not forget there is another factor, which is this one. So now we're going to write the values or the factors of our cubic function. So we have x is equals to half, x is equals to 3, and let us not forget this one, which is x is equals to negative 2. So finally we have what we call x-intercepts. So our x-intercepts, x is equals to half, x is equals to 3, and x is equals to negative 2. So what we are going to do now is we are going to sketch the curve, because we now have the y-intercept, which is 0 to 6, and we also have x-intercept, which is x is equals to half, 3, or negative 2. Let us sketch our curve. So sketching our curve, so we are going to sketch our curve in this case, and we have our x-intercept, and we have our x-intercept. Because we know that a was positive, so we know our graph is going to start from this other side, and we have our graph, which is this one, y-intercept, x-intercept. Our y-intercept was 6, so we're going to put our 6 here, and then we have x is equals to negative 2, which is the first value. Then x here is going to be negative 2, x is negative 2, x is also half. We're going to put x as 1 over 2, x is also 3. We put x is equals to 3 in this case. So basically we have plotted we have sketched our cubic function with the function f of x, our original, which is 2x cubed minus 3x squared minus 11x plus 6. So finally we have our x-intercepts and our y-intercept. Our y-intercepts plotted properly. So thank you guys for watching this video. Thank you for taking your time to watch, and we'll meet again in other videos.